Welcome to True Projects. In this video, we are going to explain about the project, which is Automatic Thyroid Ultrasound Image Classification using Feature Fusion Network. Introduction. The global prevalence of thyroid nodules have been steadily increasing over the years, making it a significant health concern that poses a threat to human well-being. Early diagnosis of thyroid nodules is very important. The diagnostic methods of thyroid nodules mainly include ultrasound examination, CT examination, aspiration biopsy, and pathological examination. CT examination requires nuclear scanning, which is harmful to patients and it is also expensive. Traditional methods for diagnosing thyroid nodules rely on clinical assessment, which is labor-intensive and resource-heavy, often requiring significant manpower and medical resources. The project addresses a crucial medical need by streamlining thyroid nodule diagnosis, potentially reducing patient anxiety and healthcare resource utilization. Feature Fusion Network is introduced, which merges texture features and deep learning features for improved accuracy. Objective. The primary objective of this project is to create an automated system that is capable of distinguishing between benign and malignant thyroid nodules in ultrasound images. The project's aim is to expedite the diagnostic process, minimizing the subjectivity in diagnosis and provide timely and reliable results to both patients and medical professionals. The project utilizes convolutional neural networks for deep learning and feature extraction as well as texture feature analysis to enhance diagnostic accuracy, aiming that these algorithms aid in extracting meaningful features from ultrasound images, enabling the system to recognize subtle patterns that may indicate malignancy. The combination of CNNs and texture features enhance the accuracy of the diagnosis. For implementing this project, we need hardware and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. In software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to execute the project. The first one is importing the packages. This module involves importing the necessary software libraries and packages, which are NumPy for data manipulation and Pandas is also for data manipulation, sklearn for machine learning, Seaborn and Matplotlib for visualization, and TensorFlow for deep learning. Exploring the dataset. In this step, the module examines and assesses the dataset containing ultrasound images of the thyroid nodules. Image processing with torch vision for feature fusion. This module is responsible for pre-processing the images, including tasks like resizing, tensor conversion, normalization. Coming to the fourth module, which is visualization of sample images, it involves creating visual representations of sample images to better understanding of the dataset. Model building. This step encompasses the creation of feature fusion models. Specifically, Feature Fusion ResNet 18. A ResNet 18 architecture is employed with additional feature fusion techniques. This model is designed to extract relevant features from ultrasound images for thyroid nodule classification. It serves as one of the neural network architecture for the feature fusion approach in classifying thyroid nodules. Feature Fusion VGG, which is Visual Geometry Group. This architecture with feature fusion techniques is used like ResNet 18. This model is customized to extract crucial features from ultrasound images. It acts as another neural network architecture for feature fusion in the thyroid nodule classification process. Training the model. This phase involves training the feature fusion models and building them for another use. From ImageNet. Image processing. This module focuses on preparing the ImageNet dataset for use, including tasks like image rescaling, shear transformation, zooming, horizontal flip, and reshaping. Data extraction to train and test split. It involves splitting the data into training and testing sets, a crucial step in machine learning. Building the model with TL. In this step, the module constructs models using transfer learning techniques, including ResNet 50. It is a pre-trained deep convolutional neural network architecture with 50 layers. In this project, it is fine-tuned using transfer learning to adapt to the task of thyroid nodule classification. It is employed because it is known for its depth and ability to capture complex image features. Fine-tuning it is one of the thyroid nodule dataset enhances suitability of the dataset. VGG16. It is another type of pre-trained deep CNN architecture, specifically with 16 layers. It is fine-tuned through transfer learning for improved performance in thyroid nodule classification. Mobile Net. It is a lightweight and efficient CNN architecture designed for mobile and embedded applications. In this project, it is adapted through transfer learning to the thyroid nodule classification task. GAN, which is Generative Adversarial Network. It consists of two neural networks, a generator and a discriminator trained together in a competitive manner. This can be used for various tasks including image generation and enhancement. Training the model and building. This phase includes training the transfer learning models and making them ready for evaluation. For machine learning. Image processing for ML. This module is responsible for processing images specifically for machine learning models involving tasks such as using OpenCV, reading the images, resizing, converting into arrays. Model training for the dataset. It involves training the machine learning models, which are KNN. KNN is a non-parametric machine learning algorithm used for classification tasks. It classifies data points based on the majority class among their k nearest neighbors. Logistic regression. It is a simple yet effective classification algorithm that models the probability of a data point belonging to a particular class using logistic functions. It is chosen for its interpretability and efficiency in binary classification tasks. Voting classifier. A voting classifier combines multiple machine learning models and aggregates their predictions to make a final decision. It is used to improve overall classification accuracy by leveraging the strength of multiple models. In this context, it combines the prediction of KNN and logistic regression for more robust results. Training the model and building the model. This phase encompasses the training and building the machine learning models for classification. Flask framework with SQLite for sign-up and sign-in. In this module, the Flask web framework is employed along with SQLite for creating user authentication features including sign-up and sign-in functionalities. User gives input. This step involves user providing input or uploading images for nodule diagnosis. The given input is pre-processed for prediction. The input images are pre-processed and prepared for the prediction step. Train model is used for prediction for about image. The trained model are used to predict whether the uploaded image depicts benign or malignant thyroid nodules. Final outcome is displayed through frontend. The prediction results are presented to the user through the web interface indicating the diagnosis of the thyroid nodule. For execution, we need to open the code folder of the project. This is the code folder of the project which contains source code files. This is a static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder consists all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. For execution, we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this path and open the Anaconda prompt. So here, using the cd command followed by the space, we will paste the copied path and then click on enter. By doing this, the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, and the port number unless configured differently. So this is the port number and this is the localhost. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I prefer Google Chrome. I will paste it in that. Here we will paste the link and then click on enter. This has redirected to the homepage of the project, which is displayed in the web browser. And this front end is built by using the Flask framework. Now we'll click on sign up. So we need to fill all these registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are my username and the password. And now I'll click on sign in. So here we need to upload the images, which are ultrasound images. For that we will have the predictions, which are the benign thyroid or the malignant thyroid or else no thyroid. Now we'll click on choose file. Now I'll select the first image and click on open. Now we will click on upload. So based on the given image, it is predicted that the diagnosis is malignant, which means the thyroid is malignant type. Now we will give the another input image. So I'll choose this one image and now click on open. Now we will click on upload. Based on the given input image, it is predicted that the thyroid is benign type. Now we will try with the other image. We'll upload this image and click on open. Now we'll click on upload. Based on the given image, it is predicted that the patient is normal, which means he has no thyroid. In this way, we can upload any ultrasound image. For that, we will have the predictions whether the person has thyroid or not. If the person has thyroid, it will predict whether it is malignant or benign. Now we will sign out of this web page. The project has achieved a successful automation of thyroid nodule classification in ultrasound images through the integration of CNNs and texture features. The developed system excels in accurately discerning between benign and malignant nodule, outperforming traditional techniques and standalone CNNs. Automation streamlines the diagnostic process, making it more efficient and accessible, potentially alleviating patient concerns and optimizing healthcare resources. The project's innovative approach carries significant potential to transform medical imaging and diagnosis, offering the prospect of early detection enhancement for thyroid nodule and improved global patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.